isn't a lot of direct competition essentially to Shutter. However, there's generally different sort of approaches how to deal with MEV, right? And usually Shutter is differentiated from this because it tackles the problem one level deeper. So most MEV solutions are kind of just bolted on top and are quick fixing the problem, which is sort of like fine for the short term, but is not actually reducing MEV, but rather just redistributing MEV. And also in some cases, it's problematic because it actually then acts to increase the trust assumption, right, and entrenches some of these centralized, as you mentioned, right, the centralized sequencer. Then if you then utilize a solution which puts even more trust on that centralized intermediary, that's actually not good for the long term. As I said before, it's like that's not how we want to have blockchain to be sort of censorship resistant and decentralized. So that's essentially where Shutter differentiates. And then I guess there's some other interesting encrypted mempool solutions which use hardware type of encryption, which is an interesting approach. However, there we would argue that it's actually more powerful to use this type of decentralized threshold encryption approach, rather trust the sort of the decentralization and the threshold encryption, rather than having to trust the hardware kind of trusted execution environment, let's say Intel SGX, right? We've seen a bunch of issues with Intel SGX, but I don't want to fully dismiss it as something that we are even looking into combining into kind of like call it fortified Shutter, so that you would have the Shutter keepers running inside SGX enclaves. So that's an interesting way to combine these, and then you would have to break both the threshold encryption trust assumptions and the SGX enclave.